All right, we need to talk about, now that we know how to simplify, we need to talk about doing operations with radicals. In particular, there's two operations we need to talk about. We need to talk about adding and multiplying. And of course, in there we have dividing and subtracting. They all go together. So one aspect that we're going to talk about is we're going to talk about adding and subtracting. And then we're also going to talk about multiplying and dividing, but really we're going to talk about dividing. I'm not giving you a full lesson on all the operations that we can do with radicals. I'm only giving you what you need in order to be successful with the tools in quadratics. Okay, so please understand that you're getting sort of an abridged version of doing operations with radicals because I'm not giving you anything more than exactly what you need in order to deal with the quadratic formula and to deal with completing the square. So we're gonna talk about adding and subtracting, and we're going to talk about dividing. So let's start with adding and subtracting. Just like with fractions and with monomials, with fractions, in order to add or subtract fractions, you need to have a common denominator. In order to add or subtract monomials, you need to have like terms. Well, radicals are the same way. You can't add something that has a radical to something that doesn't have a radical. So if I were to give you something like 5 plus radical 24, you can't combine these in any way because this doesn't have a radical, this does have a radical. Those can't be combined. So instead, we're just going to simplify it as best we can. So you're going to apply your rules of simplification to this radical 24. I'm going to streamline that process a little bit from the last lesson because you should be getting better at that by now. So we're going to have the 5 plus is just going to stay out front. Radical 24, the biggest perfect square that goes into 24 is 4. So I'm going to write this as radical 4 times radical 6. And then this is a perfect square, so I'm going to take the square root of that. And I got 5 plus 2 radical 6. And that's as far as you can go with that. Okay, that's it. When it comes to adding and subtracting radicals, that's as far as you're going to go. Let's take a look at one more example of basically the same thing. What if it were to be something you might be something like this? You could see negative 3 plus or minus 2 radical 32. And again, I wanted to put this particular symbol in here so that you get accustomed to working with it. For now, all you need to do is just keep that symbol the same. So the negative 3 plus or minus is just going to come down. And now what I'm really doing is I'm really simplifying 2 radical 32. So the biggest perfect square that goes into 32 is 16. So I've got 16, and 16 times 2 gives me radical 32. There's my perfect square. So negative 3 plus or minus 2 times 4 radical 2 gives me negative 3 plus or minus 8 radical 2. And that's it. Okay, so that's all it is for adding or subtracting. If this was just a subtraction sign, then you would just leave those all as subtractions. Fairly simple. What you're really doing is you're simplifying the piece that has the radical. Everything else just sort of comes down. Now, what about dividing? Once again, you can divide things that don't have a radical with something that does, but you have to be careful. Let's take, for example, this right here. Let's say, let's say you have radical 72 divided by 2. Here's what you can't do. You can't divide 72 by 2. And the reason why is you cannot divide something that's inside a radical with something that's not inside a radical. So you're not allowed to do 72 divided by 2 and get the square root of 36. Doesn't work that way. Okay? Here's what we're going to do instead. We're going to simplify the radical 72 part. We're going to simplify this first. So the biggest perfect square that goes into 72 is 36. So now I've got radical 36, and 36 times 2 gives me 72 over 2. Okay, so I just brought the over 2 down. Now let me take the square root of radical 36, so now I have 6 radical 2 over 2. Now I can do some dividing. I can't divide 2 and 2 because, once again, this is inside a radical, this is not inside a radical, but I can reduce these guys right here. 6 over 2 is 3, and the radical 2 just comes along, and that is fully simplified. Okay, 3 radical 2. Let's take a look at another one of those. So let's say I have negative 5 radical 27 over 3. All right. I can't divide 27 by 3 because the 27 is inside the radical, the 3 is not, and negative 5 doesn't reduce with 3, so I'm kind of stuck here at this point. So what I'm going to do is I'm going to simplify that top. So I've got negative 5, radical 27, the biggest perfect square that goes into 27 is 9. So I've got radical 9, and it's 9 times 3, gives me 27, all over 3. Don't go dividing here. I know you want to, but you can't. This is underneath the radical, this is not. Can't divide those. And you can't divide here either because 9 is also inside a radical. Instead, I'm going to take the square root of 9. So now I've got negative 5 times 3 times radical 3 all over 3, which is negative 15 radical 3 over 3. And now I can do a little reducing. Not the 3 and the 3, because that's inside and that's outside, but negative 15 over 3 is negative 5. So this is negative 5 radical 3. Now, if it doesn't divide evenly, like if you had, say, a 5 here and a 10 here, then you would just make that 1/2. You would reduce it how you would normally reduce it. And I'm going to show you some examples of that in a little bit here. But what I really want to do now is I want to put those two things together, because this is what you're going to see when you're dealing with the quadratic formula. Okay, I want to put those two things together, and I want to give you something like, let's say I gave you, let's start easy. So let's say I gave you 6 plus 3 radical 2 over 3. Okay, what I want to do here is I want you to notice that 6 can reduce with 3 and 3 can reduce with 3. So what we're going to do is we're going to reduce here and we're going to reduce here. 6 over 3 is 2 plus 3 over 3 is 1 radical 2. That's actually what you're going to do there. It's that simple. Okay? Reduce the things out front with the piece that's being added or subtracted out front, and reduce your coefficients with the denominator. Now I can make this a little bit harder just by giving you some simplifying to do first. Let me show you what I mean. You could end up with something like this. How about 8 plus radical 20 all over 2? Okay, now I know what you want to do. You want to start simplifying right away. You want to start maybe 8 divided by 2 is 4. Okay, let's just slow down a minute, and whenever we do these problems, let's simplify our radicals first. So here's what I'm going to do. I'm going to do 8 plus. Radical 20 is radical 4 times radical 5 over 2. I'm going to take the square root of radical 4. So 8 plus 2 radical 5 over 2. And now I'm going to do my reducing. 8 over 2 is 4 plus 2 over 2 is 1. You can write the 1 or not, so I could just write radical 5 there. If you want to put a 1 in front of the radical 5, that's totally fine. All right, one more. So let's make this one. This is really what you're going to see when you're doing quadratic formula. You're going to end up with something crazy like this. Okay, first step. Let's simplify this radical 162. Well, I'm going to save you some time. The biggest perfect square that goes into 162 is 81. So now I have negative 3 plus or minus, that symbol just comes down, radical 81, and it's 81 times 2, gives you 162. This is all over 5. Square root of 81 is 9, so now I've got negative 3 plus or minus 9 radical 2 all over 5. And now I'm going to take a look at this. Does negative 3 reduce with 5? No. Does 9 reduce with 5? No. And so I'm done. This is my answer. The rule here is they either both get reduced or neither get reduced. So here's what I mean by that. Let's just say, for example, let's say, I'm just making this up, let's say that you had 6 plus or minus 5 radical 2 over 2. Let's say you had that. Here's what I want you to notice. Notice that 6 could reduce with 2, but 5 doesn't. Because the 5 doesn't, this would be your answer. Don't go any farther with that. Okay? You can't reduce the 6 and the 2 and not reduce over here. And since these two don't reduce nicely, you would just leave that. So you either reduce both or you reduce none. You're not allowed to just reduce one out of the two. I hope that makes sense. We're going to practice this a whole bunch in class, and hopefully you'll get real comfortable with this. And in the next lesson, we're actually going to start solving some quadratics. And before you know it, we're going to be applying this skill for solving quadratics.